about ion formation. So previously we've looked at the structure of the atom, we've looked at electrons, protons, neutrons, and where they are within the atom. What we're looking at now is why atoms are attracted to each other and why they stick together. So we're going to look at how ions are formed and how they eventually go on to form bonds. So we have a look at this first slide here. We're going to look at the idea of what bonds actually are. So very few elements will actually exist just as a single atom. They will normally be bonded to something else. And the reason why they are bonded to something else is because they are unstable. And that's the first thing we're going to have a look at today as we go through and build up our understanding of ions. So look at the next slide. A diagram that you'll be very familiar with. So we can see inside that diagram we've got the central nucleus with the protons and the neutrons. You should be remembering that the protons have got a positive charge, the neutrons have no charge. They both have a mass of 1. Around that nucleus there are the electrons. The electrons have a negligible mass but a negative charge. You should also remember that the electrons are not randomly positioned. They occupy specific shells. Depending on the number of electrons in an element will determine how many shells that element will have. We only need to be concerned about the first 20 elements of the periodic table for our GCSEs, so we won't go past 20 electrons. So in this example here we can see, as always, there are 2 electrons in the first shell closest to the nucleus. That is the maximum number of electrons that that shell can hold. So if an element has 2 electrons, that shell would be full. If an element has 3 electrons, then we would move up to the next shell, which is the second shell. The second shell can hold a maximum of 8 electrons. So within those first 2 shells, we can have 2 in the first shell and 8 in the second shell. So any element that has up to 10 electrons would have those first 2 shells. When we go on to 11 electrons, we then move into the third shell. That third shell can hold just 8 electrons. Now, what we're really concerned about is what happens at the outermost electron shell. Now, if that outermost electron shell is complete, so there are the maximum number of electrons in that shell, that element is considered stable and it will not react with anything. So in this example here we have 8 electrons in the outer shell. This will make this element here completely stable and it will not react with anything else. It will not react to form a bond. If there are only 7 electrons in the outer shell, that would make it unstable and that element would do something to form a bond. And that's what we'll be looking at in this lesson. So the really important thing to remember is it's about the outer electron shell and whether it has a full number of electrons, whether it is complete or not. So we've just talked about this idea here about outer shells being completely full, stable. If they are not completely full, they are unstable. I'll include this in the this PDF file in with the lesson assignment so you can go through it at your own speed as well. Now, if we have a look at some of the groups in the periodic table, group 1 has 1 electron in the outer shell. Group 2 has 2 electrons in the outer shell. Group 3, 3 electrons in the outer shell, and it goes on like that. And we can see group 8 or group 0, depending on what periodic table you're using, has 8 electrons in the outer shell. So if I just bring up my periodic table and quickly go through it here. So if we have a look at group 1, as we move down here, so here's group 1, and remember we're going down when we're describing groups: lithium, sodium, potassium, rubidium, cesium, francium. They're all in group 1, they all have 1 electron in their outer shell. Now that makes them unstable because the outer electron shell is not complete. So all those elements are unstable. They will react with something to form a bond. Group 2 has 2 electrons in the outer shell. So we've got beryllium magnesium, calcium, strontium, barium, and radium. They only have 2 electrons in the outer shell. They should, and those shells have 8 electrons. They are unstable because the outer electron shells are not complete. Moving through the transitional elements. Group 3, 3 electrons in the outer shell, unstable. Group 4, 4 electrons in the outer shell, again unstable. And it's the same as we go through group 5, group 6, group 7. When we get to group 8, slightly different. So if we look at this periodic table, we can extract some information as far as the number of electrons go. So we know helium has a proton number of 2. If it has 2 protons, it has 2 electrons. And it has 2 electrons in that first shell. The maximum number of electrons that first shell can contain is 2. So helium has a full outer shell. Helium is stable. It will not react with anything. Moving down to neon. Neon has 10 electrons because the atomic number is 10 and that tells us it has 10 protons. So if an element has 10 protons, it must have 10 electrons. Now, going through, if I just move this and go back a slide and we look at our electron diagram, the first shell contains 2. The second shell contains 8. So if we have 10 electrons, that first shell has taken 2 and the second shell takes up 8, making neon a stable element because it has a full outer shell. So the key thing to remember here is if an element has a full outer shell, it is completely stable and it will not form a bond to become stable. So, flicking through, you should be able to pause the video now and explain why groups 1 to 7 are unstable and why group 8 or group 0, depending on which periodic table you're using, is stable. So pause that, have a look back through the slides, have a think about it and see if you can get the answer. What you really need for this is to show that you understand that in groups 1 to 7, the outer electron shell is not full. And in group 8 or group 0, they are a full or a maximum number of electrons in those outer shells, making them stable. And that's all you need to be able to say for that kind of question. Okay, so moving on and seeing what happens because these elements are unstable. Now, elements will form a bond with another element because they are unstable. Now, there are different types of bonding that we're going to have a look at. Set 1 have already looked at ionic bonding, but we are consolidating that and we're going back through it again. There's also covalent bonding and there's also metallic bonding. All 3 we'll need to look at this year and next year for the GCSE exams. Now, what we're going to have a look at specifically is ionic bonding. Now, this is a really, really key point. It's normally a 2-mark exam style question. And it will ask you what an ion is. Now, an ion is an atom or group of atoms that has lost or gained electrons to become charged. Now, we need to look at why it would lose or why it would gain electrons. So if we use this picture for an example, if we look here, we've got 2 electrons in the most inner shell, and then we've got 1, 2, 3, 4, 5, 6 electrons in the outer shell. So we know it's in group 6. Now that shell contains a maximum of 8 electrons. So is that a stable element? It's not, because it doesn't have a maximum number of electrons in its shell. It only has 6 and it needs to have 8. Now, the element will do something to become stable. There are 2 things it could do to become stable. It could lose 6 electrons and lose that shell completely and go down to that first shell, and there would then be 2 electrons in the outer shell and it would need to lose 6 electrons. Or it could gain 2 electrons. And the easiest way to think about this, as far as remembering it for exams goes, the atom will do the simplest thing, the easiest thing. So it's much easier to gain 2 electrons. So this element here will gain 2 electrons. That will then make the outer shell complete and make it stable. Then we have an ion. We also have positive and negative ions to look at. So we'll go through and have a look at a diagram which will explain this in a little bit more detail. So if we look at sodium, sodium is in group 1. Sodium has 1 electron in the outer shell. So a sodium atom is unstable. It has 11 protons, taken from the proton number, and 11 electrons. That means that it has no overall charge. As we said last lesson, the number of protons equals the number of electrons, so there'll be no overall charge on a sodium atom. But it is unstable. It needs to do something to become stable. It needs a full outer shell. So sodium will lose its outermost electron. If we look at the sodium ion here, it hasn't lost any protons. Nothing's happened inside that nucleus. So all the protons are still there. But it has lost an electron. So now we do not have the same number of protons and electrons. There's an imbalance. There are 11 protons, so 11 plus charges. But there are 10 negative charges. So overall, even though that sodium ion is stable, it has a positive charge. So sodium has lost an electron and formed a positively charged ion. It has a positive charge of just 1 because it has lost 1 electron. If we have a look at another example, magnesium. Again, if we have a look at the magnesium atom over here, the magnesium atom has 12 protons, 12 electrons, because atoms have the same number of protons and electrons. Because there are equal numbers of protons and electrons, there is no overall charge. Looking at the diagram of the electron arrangement, we can clearly see magnesium has 2 electrons in its outermost shell. That makes it unstable. It needs a full outer shell. 2 things that could happen. It could lose 2 electrons, or it could gain 6 electrons to make it stable. The element will do the easiest possible thing, which is to lose 2 electrons. Now, we have not lost any protons. Still 12 protons in the nucleus. But we've gone from 12 down to 10 electrons. So because we have got an imbalance, we've got 12 positive charges and 10 negative charges, we have an overall charge of +2, creating a magnesium ion with a charge of +2. Now, the key thing to remember there is that if an element loses electrons, it's losing negative charge, which means that ion that is left will have a positive charge. Negative ions must be gaining something negatively charged, and the thing they are gaining is electrons. So if we look at fluorine, for example, fluorine has 7 electrons in the outer shell. It is unstable. It needs to do something to become stable. It needs to gain an electron. That will then give it 8 electrons in the outer shell. That extra electron has now messed up the balance of the positive and the negative charges. So in a fluorine atom, we have 9 protons and 9 electrons, no overall charge. But in a fluoride ion, even though it's now stable, we've got a negatively charged ion because it has 9 protons but 10 electrons. So there is an extra negative charge. Sulfur, similar example. If we look at a sulfur atom, it has 6 electrons in the outer shell. It has 16 protons, 16 electrons. It is unstable because it only has 6 electrons in the outer shell and it needs a full outer shell, and in this case that would be 8 electrons. To get that full outer shell, it needs to gain 2 extra electrons. Now, when it gains those 2 extra electrons, there is an imbalance between the number of protons and electrons. We have 16 protons and now 18 electrons. So there are an extra 2 negative charges. So here we see that sulfur has turned into a sulfide ion with a negative 2 charge. So if an element gains electrons to form an ion, it will form an ion with a negative charge. Now, these points here are what we need to be able to answer based on those questions. So this is the sort of the assessment task. This is the thing that will show me whether you've progressed through and understand what we're talking about. So you can have a go at these. I'll put them on a Google Docs for you. You can write the answers in underneath. But you need to be able to explain what an ion is and how an ion is different to an atom. You then need to say why an ion forms. Then you need to have a look at why do metals always form positive ions? Why do non-metals form negative ions? And then explain, with the examples we've used, why magnesium forms a 2+ ion and why oxygen forms a 2- ion. If you understand those and you can answer those questions, and we'll look at those in our feedback session on Friday, you'd have really got to grips with what we're talking about here. Now, it would be really good if you've watched this video, but then have a look at the animations and the other videos that I'm going to put up for the lesson, and then have a look at the textbook page as well, which has some other more information on it, and you should get to grips with this. But this is a real fundamental part that we need to get sorted before we can move forward. So on our Friday's lesson, when we're looking at feeding back, it's very important that you come to that lesson having done this, so we can then discuss if we've got any issues. Thank you very much, and I'll see you next time.